afternoon, everyone. My name is Amberly, and I'm the program manager here at the Asphalt Pavement Alliance. We're so glad you joined us for today's webinar. Today's session is Situational Awareness, Trends in the Asphalt Industry. It actually officially kicks off our 2026 webinar program, and we're so excited to start the year with such a timely and important topic. Before we begin, just a quick housekeeping note. This webinar is being recorded and we'll actually upload it to APA's YouTube page by the end of the week. So there's no need for you to record, but you are encouraged to take any notes. And if you have any questions, you can drop them in the chat and we'll try to monitor them. And then at the end of the webinar, we'll see if we should have a few minutes left. We'll try to answer as many of your questions as we can. If we don't get to all of them, we'll follow up to you with an email of your specific answer to your question. A quick look ahead. Since this is the kickoff for our webinar program, our next webinar is actually scheduled for Tuesday, July 7th, and that'll be presented by our technical director, Buzz Powell, who is actually joining us on call today as well. That session will focus on HP binders and high mod mixes. Towards the end of our webinar today, I'll drop a link in the chat, which will take you directly to that link. So if you want to go ahead and register, you're more than welcome to, but it'll also show you all of our other upcoming webinars we have throughout the year. So without further ado, it's my pleasure to introduce today's speaker, Mike Skinner, Executive Director of the Asphalt Pavement Alliance. Mike works closely with industry partners, government agencies, and stakeholders to advance APA's mission and ensure alignment with national infrastructure and sustainability goals. Mike brings more than 34 years of experience in asphalt pavement engineering, along with over a decade of trade association leadership. Prior to joining APA, he served as Senior Director of Engineering for the Colorado Asphalt Pavement Association, where he played a key role in shaping statewide asphalt initiatives, advancing sustainability programs, and strengthening partnerships across agencies and industry groups. His career spans engineering consulting, association management, technical leadership, and advocacy at both the local, state, and national levels. Mike holds dual credentials as a licensed professional engineer and certified association executive, reflecting his ability to bring deep technical expertise with strategic organizational leadership. So without further ado, please join me in welcoming Mike Skinner. And Mike, I will turn it over to you.
Thank you, Amberly. As Amberly mentioned, the decade prior when I was worked for the Colorado Asphalt Pavement Association, I'm still located here in Denver, Colorado. And we, as the Asphalt Pavement Alliance, Amberly is located in Lexington, Kentucky. I'm in Denver, Colorado, and our technical director, Dr. Buzz Powell, is located in Auburn, Alabama. But what you're seeing here on the slide is my home state in Colorado. This is US Highway 550, the $1 Million Highway, named after its views. This is the highway that connects Durango to Ouray in the southwest corner of the state. It's a beautiful section of highway. But what's interesting about this section of highway is you'll notice there's no guardrail on this section of highway, so it can be kind of scary if you're in the photograph coming toward us, which means you're on your way to Durango, and if you're on that outside lane, and if you're behind a fifth wheel that's from out of state, and they're sightseeing here across Colorado, they can be very slow and it can be a little nerve-wracking. But the reason there is no guardrail on this section of the $1 Million Highway is because this section of highway in Colorado is the most active avalanche zone in the state of Colorado. This is Red Mountain Pass, and right around the corner from this photograph is the most active avalanche chute in Colorado. And when an avalanche would come down and CDOT would have to go in there and clear the snow, if they had to close Highway 550, it resulted in almost a 2.5 hour detour. You had to go all the way around through Cortez and the Telluride Ski Resort. So they do everything they can when we talk about resilience of not only from construction of materials, but resilience in keeping the road open. And so the reason there are no guardrails here is because it makes it easier for CDOT to plow snow. In the wintertime, they can just shove it right off the side of the road and it doesn't pile up and infringe on the lanes, because you'll notice there's no shoulder or minimal shoulder on this section. But like I said, right around the corner is that most active avalanche chute. And because it slides so frequently, CDOT has actually built an avalanche tunnel on that chute. So when the slides come down, it just goes right over. It's like a little tiny tunnel, like a wildlife crossing. You just drive through it, and you wouldn't even know there's an avalanche going on above you. It just slides right over the roof. It's an angled roof, and it just goes right down to the canyon there. So just a little tidbit. If you're out around driving around the country this summer, and if you find yourself out here in Colorado, make a drive on 550. It's a beautiful scenic highway. But before we get into our situational awareness and what's new and trends across the industry, I'd like to take a look backwards. First, we're celebrating a couple of highlight anniversaries this year. Number one, I would draw your attention to the APA, which was founded in 2001, and we'll talk about the mission here of the APA in just a minute. But we are celebrating our 25th anniversary. This photograph is an existing remaining section of Route 66 in New Mexico. Route 66 is celebrating its centennial celebration this year. The original segments were constructed in 1926. This piece that we're looking at right here was constructed in 1928. This is about 20 miles south of Albuquerque. New Mexico holds the distinction of having the longest segment of Route 66 across the state. And this performance just highlights 100 years of asphalt high quality performance and long life pavements. This segment that we're looking at right here won a Perpetual Pavement Award last year, demonstrating that while it had been maintained and has been resurfaced since 1928 multiple times, it's never had more than 4 inches of additional material placed on it as an overlay, and it's never experienced the structural failure. That's why it met the criteria for performance on life winner. The Asphalt Pavement Alliance, who are we and what do we do? So we represent the stakeholders of the asphalt paving industry, and we are the industry promotion portion of that. So we work with the National Asphalt Pavement Alliance, the Asphalt Institute, and the individual SAPAs. Every state does not have a state asphalt pavement association. The Dakotas are combined, but there are 40 SAPAs, and together they make up SAPA Incorporated and the Asphalt Pavement Alliance. We live in the middle there, and we represent the core common missions for all of these groups and stakeholders, representing quality, long life performance, and influencing pavement type decision makers and technology transfer to advance our industry. So if we look at a map of the United States, and the interstate highway system is blue here, and the state highway system is red, the Asphalt Institute does a wonderful job every year summarizing this data. And there is a report that each DOT has to submit to the Federal Highway Administration, the FHWA, each year, documenting how many lane miles of highway, interstate highway, and non-interstate that they have in their state, and what it's surfaced with, asphalt, concrete, or unimproved, if it's gravel or something else. And so the Asphalt Institute pulls those 50 reports and pulls this number. So you've heard this number before. 94% of the roads in America are paved with asphalt. Where did that number come from? How do we come up with that number? Is it just a marketing? Is it a tagline? No, it is not. It's a synthesis of that research that the Asphalt Institute updates every year. But that's where that number comes. You've heard that if you've been in our industry for a long time, but that's the genesis of where that comes from. Let's take a look at a little bit of history as it relates to our market share as far as the material side. So using some data and information shared to us from the Asphalt Institute, in 2001, there were 150 operable refineries across the United States. 48 of those 150 produced asphalt. Fast forward 2 decades to 2024, and that number has dropped to 132 refineries, where only 43 of them are now producing asphalt. So we've seen a drop in about 12% in the actual supply side ability, but production has actually increased because of changes in technology, refining technology. So even though the number of refineries has decreased, production and output has increased. How much has it increased? We look at their next slide with their where they track. This is not asphalt tonnage. This was asphalt liquid binder tonnage. And if we just focus in on the green line, which is the liquid asphalt that is used in paving, you can see the highlight, the heyday over the last 2 decades was in the early 2000s, over 30 million tons of liquid binder, then a decrease in 2008 with the recession. The low point was in 2011, where the industry was down to just 14.6 million tons of liquid binder. And then we've seen a slow, steady increase into to where we are today. In the last number that was reported in 2024, a year and a half ago, we are knocking on the door at just about 21 million tons of liquid binder, which is another metric so that we can use to measure market share, the growth and sustainability of our industry. Why does asphalt dominate road construction? I love this photograph and I love this tagline. This was on the cover issue of the Asphalt Institute Summer Magazine last year. And we can really put it down into a couple of different buckets, a couple of streamlined answers. But initial cost of construction is one of the key reasons why our industry dominates road construction. And I'll give some examples about that in a minute. The new emphasis that our industry is putting on streamlining specifications and making our specifications without sacrificing quality, making them more user-friendly and more flexible for the producers, and this is in the realm of balanced mix design. We'll talk about that in a few minutes. Materials innovation, this is a big one. We'll spend a back half of the presentation talking about new technologies that can help solve some of the problems that I'm going to highlight here in a few minutes. And then the concrete maintenance performance has been well documented and researched. Out of the National Center for Asphalt Technology in Auburn, Alabama, they have documented the inflection point occurs at about year 25, meaning where the ROI on the maintenance, where it used to be promoted at about 40 years, is actually about 25 years based on the data that has been published by NCAT. This is the Secretary of Transportation. This is Sean Duffy. And when he stepped into office during the change in leadership, he brought a renewed vigor and a different attitude to the Federal Highway Administration and the Department of Transportation, where he said, let's get back to basics. Let's focus on building roads, maintaining roads. Let's focus on building bridges and maintaining bridges. Back to what the DOTs at the state level are good at and what they've been doing for decades. How we get there with federal funding, state level funding, has become problematic, and it ultimately is resulting in program delivery is down. And I'm going to show you some examples of that what I mean by program delivery. But some of the other trends that we're seeing across the country is industry consolidation leading to diversification. What do I mean by that? Larger companies that are acquiring new companies, new businesses is changing some of their business plans. Where if they were primarily a contractor or producer and they buy a milling company or they buy a striping company or they buy a stabilization company, now that they're in that business too. Or if you had a surface treatment company, preservation company that buys a milling company. So we're seeing this diversification, consolidation leading to diversification in business plans. Innovation, high mod is a highly modified asphalt. The successes that we're seeing around the country with high mod is really quite spectacular. And I'm going to share some examples of what Utah is doing with their high mod and how they are blazing a trail. And lots of other DOTs are paying very close attention to what is happening in Utah and how they're using that high mod. Then when I talk about trends, I like to wrap it up with the general thought about progress, not perfection. And this is a mantra that I would share with the DOTs, share with agencies, share with contracts, share with our industry in general. If you're waiting to roll out a program, if you're developing a program, whether it be a new specification, implementation of a new design methodology, a new material, etc. If you're waiting for it to be perfection, you might be adding a month, a year, 10 years to that rollout. 70% is good enough. And I don't say that with respect to quality. I'm saying about implementation of the program. Get the program started, and then as you're implementing it, moving it forward, it can evolve, it can refine, and it can improve. But don't wait until you get the perfect program to roll out. Roll it out when you're targeted when you're 70% ready. As long as we're not impacting quality. That's always the hallmark and the core of everything that we do in our industry is quality. But progress, not perfection. Let's get the ball moving. Now, getting the ball moving, it always comes back to this discussion about funding. And so I'm going to talk for a few minutes here about funding. And so we'll first focus on initial cost of construction. One of the things that we do that's important to us at the Asphalt Pavement Alliance is when we share information, examples, is that it's data driven and that we have the information, the technology, the data to support the facts that we're talking about. So when I talk about asphalt industry, it dominates our industry because we have a lower initial cost of construction. Here's just two examples that come from Michigan, where they have a lot of life cycle cost analysis that they do for their projects there in Michigan. But if we look at just this project, an I-94 reconstruction project, they pull those future costs back to present day value, and the numbers aren't terribly important. I just want you to look at the difference for the asphalt reconstruction option versus the concrete reconstruction option is a lower initial cost of construction. And then the EUAC, or the equivalent uniform annual cost, also is reflected in initial cost of construction, lower cost of construction. Take a look at a second project there in Michigan. Alternative one was to reconstruct with asphalt. Alternative two, reconstruct with concrete. Again, the numbers aren't terribly important. It's just to look at the difference. This project, those costs were broken down, cost per lane mile, and it was about $623,000 per lane mile for the asphalt option versus almost $693,000 initial cost of construction for the concrete option. When you look at this across the United States, you can, regardless of what local agency, city, county, municipality, Department of Transportation, you'll find this trend across the country that the asphalt option is almost always a lower initial cost of construction. So that's helpful. But the funding, the budget that becomes available is really what's driving the success or lack of success of these programs. And I love this quote from Nye. He is the regional materials engineer for the North Central Division for the Arizona Department of Transportation. Nye is based in Flagstaff. So he's up at 8,000 feet. But I was talking to him last year, and Nye said, Mike, listen, in Arizona at the Department of Transportation, we're not in pavement preservation mode. We're in pavement life support mode. And those of you that may be in the Arizona market probably would agree with that. The roads in Arizona are rough. And there's a lot of reasons for that, but we won't get into. But the concept can apply probably to the state that you're in. It's not in preservation, and I don't mean preservation in terms of surface treatments, those type of things. I meant preservation in general, maintaining your network. It's in life support. Why are things so bad across the country? I'll give you a couple of examples. Here's an example in Oklahoma, where they have 8 different districts for the DOT across the state. And they maintain about 30,000 lane miles in Oklahoma. But their average, based on their funding level right now, they're only treating about 1,200 lane miles per year out of those 30,000. So they're not even hitting about 4% of their network each year to get through that. So to cycle through their entire network and hit 100% of the road, it's a 26-year cycle to get around and do that network in Oklahoma. Perfect example where their only viable path for their DOT moving forward with the limited budget that they currently have is to minimize their costs and maximize their return on investment, their service level, their quality, and their performance of what they are doing and what they're spending money on. Now, Oklahoma is not the only DOT that's in this condition. We could point examples for all 50 states. I'm just going to draw attention just to a couple more. This happens to be Indiana. And if you take a look at the Indiana's long range transportation plan that has funding projected out through the year 2045. What you see in the red box there, again, the numbers aren't important. What's important is to look at the trend. The number doesn't change. So they're projecting out through 2045 in Indiana to not increase the funding for the portion of their federal aid program, the resurfacing program. So with inflation, with a rising cost of construction, but a steady or stagnant funding level, you can see when I mentioned program delivery is down, here's a shining example of that. Where program delivery, you might define it in number of tons of asphalt that get placed every year. You might define it in a number of lane miles that get addressed. You might define it in an area or square feet of preservation treatments that are placed. But all of those numbers come down with minimal or stagnant flat funding. So how can you compare these states? Because they all have such different funding mechanisms, it gets very, very complicated. So one way to boil it down, one way to peel the apple is to take a look at just their resurfacing program, their annual mill and overlay program. Doesn't include maintenance, doesn't include capital projects, but their annual resurfacing program. And every DOT has something that's similar along the lines of that. But if you take the budget for that annual program and divide it by the total number of lane miles that the state is maintaining, you'll come up with the dollar per lane mile for just a resurfacing option. Now we have an apple to apple to comparison, and we can compare Indiana to other states. How are they doing? And the number isn't particularly important, but it's the comparison. If we go over here to my home state in Colorado, their funding is almost right on with what Indiana is spending at $255 million annually. The network here in Colorado is a little bit smaller than what they have in Indiana. So that's about $11,000 per lane mile. Okay, now we're starting to get a couple of data points. You can see quickly how you can kind of do this back of the napkin calculation and kind of see where your state's going to land. And then you can come down to other states like Florida, where they have that, look at that number, 1.5 billion for their surface treatment program in 2025. Their network is a little larger, about double the size, 46,000 miles, but they're spending about $32,000 per lane mile in Florida, 4 times what Indiana is spending. So when you look at the difference in performance, what's the quality of the roads in Florida or Texas or Mississippi or Indiana? This is one of those metrics that you can use just to kind of gauge where is the state and what do those funding problems look like. Another metric that you can use to measure performance in states is the FHWA Highway Statistics Table. This is roughness. So all of the states are measuring performance, drivability, remaining service life, all a little bit different. Where it is standardized is roughness, and this has to be reported to the Federal Highway Administration. Now, if you go into and search Google for this table, you'll find several different options for it: federal aid length, interstate, non-interstate, etc. So this snapshot that I have here is specifically just for the federal aid length, but they rank the states 1 through 50, and then they also include the District of Columbia, Washington, D.C. So that's why there's 51, but they're ranked number 1 through number 51 for federal aid length, and this was most recently updated in 2023. So how's your state doing? If you're focusing on the red numbers there in the far right-hand column, that's the percentage of their network that is in poor category, meaning their IRI is over 170, meaning it's very rough. and that's generally indicative of poor pavement conditions. But you'll notice about the top 20 or so, the top 17, if we get down to Minnesota, they're in single digits as part of their total amount of network that's in poor condition. And then it escalates quickly when you come down to like 45 to 51. Their numbers are very large, at least on their federal egg length. So this is a great tool if you're comparing performance state to state or where your specific state. What else is impacting program delivery? If you look at program distribution, this data comes from Pennsylvania, but if you look at just going back a couple of years, all the way back to only back to 2022, if you look at the percentage of their funding that they were spending on their highways in 2022 at 73%, at 2026, depending if you included a bridge project or not, you're down to 45 or 60%. And then the numbers that we're seeing in the other direction increase in bridges. So this is something that we're seeing across the country. Why is it? Well, our interstate highway is celebrating its 70th anniversary this year. That also means we have an aging infrastructure, and our bridges are experiencing 70 years worth of use. And so we're seeing larger and larger infrastructure programs that are having to include these massive bridge programs that is redirecting a portion of the funds from highways to bridges. And that distribution, we also saw that with the IIJA money that came out a couple of years ago. So program distribution is having a significant impact on highway dollars at your state. Another significant impact is the influence of mega projects. Like what we saw with the aging bridges, we're seeing large or significant portions of our interstate highway system that are requiring major rehabilitation or reconstruction. And so you may define a mega project that's anything over 500 million, etc. But you can see this again, this is just from Pennsylvania, but you can see the impact, the growth in the number of what we're calling mega projects, and the gravity of those mega projects. While we're still spending money on the highways, it's pulling funds away from distributing them across the state, focusing them in large scale projects, which is having an impact on overall performance across the states. So I've spent the last 15 minutes talking about impacts to program delivery and problems. Well, it's great to get an understanding of why some of these things are happening, but I don't want to leave it there. So for the next 20 minutes, I'm going to talk about some solutions that we're seeing across the country. Different states are adopting these different solutions, but how do we move forward? Innovation isn't down the road, it starts today. So I'm going to go back to my statement: progress, not perfection. So what I might be sharing with you today, hopefully there's a takeaway, one, two, or three things here that you can take back as a designer or an agency and say, you know what, I heard some great stuff. Let's move down this road. Progress, not perfection. So let's talk about expanding the use of RAP or recycled asphalt. This is Duval Asphalt down in Jacksonville, Florida, and they serve the northern Florida market. Beautiful photograph there, beautiful plant that they have down there. But what I want to draw your attention to is their use of RAP. Now, RAP varies across the country, RAP usage, RAP availability, RAP quality. So there's a lot that goes into this. So this is not a silver bullet, but there's a lot of testing that's required to make sure we're not impacting quality, maintaining quality. But what I do want to draw your attention to here is their standard mix designs are running 40% mix, 40% RAP there in the Jacksonville market. And then what they identify as their high RAP mixes are 65% RAP. Now, when we start to talk at RAP at those numbers, those are some very specialized mix designs, and they require quite a bit of attention to quality and control, but I just didn't want to put this on your radar. So if you're in a state right now or a local agency or a DOT and you're using your specification allows up to 20% wrap, and maybe your industry is typically using 15% of that 20. I'm not suggesting that you move that 20% to 30 and 40%. We're talking about baby steps here, moving the needle and your ability to do that. And this has been proven across the country that this works. Materials and innovation design. I mentioned high mod or highly modified asphalt. This isn't a material, this is a design philosophy that it increases the amount of liquid binder that you're putting in the mix, the quality of the binder and the amount of the binder, and then thick lift paving. So we can do a whole presentation on this, and Buzz will be doing a presentation on this during our next webinar that Amberly briefly mentioned. But I wanted to give you a two-slide snapshot of what that looks like. So here are four standard binders that have been in use across Utah at their DOT. The high mod is the one that's on the far right, the PG 76 minus 34. And so Howard Anderson, who's the state materials engineer there in Utah, did a quick little calculation and calculated a stack of 10 dimes is the equivalent of about 1 kilopascal. So they set the stack of 10 dimes on the surface of the binder and set a stopwatch, and then they let it run to see what the stiffness. So this is a great visual of what that stiffness looks like. Now the camera here is accelerated because you can see the time running through that. But the 5828, which is the softer binder, and we always know that is the softer, more flexible binder, the dimes have completely disappeared. And then the high mod, but here we are a day later, 24 hours later, high mod binder, the 76 minus 34 that's used in that material is showing the stiffness. What's going on here is that that binder has a higher percentage of polymer than a traditional polymer mix. That's the easiest way to think about this. And those polymers, because it's at a higher level, really start to dictate the performance of the liquid binder. The other test that they do that shows the success of these high mod binders and the things is the elastic recovery and tensile strength. So here's elastic recovery. We take this binder, we pour it in the mold, we put it in a water bath, and we warm the samples up. And this is in a sped up photograph movie here, but we slowly pull them and then we cut them with a pair of scissors, and we measure that elastic recovery. How much does it snap back? That top sample up there is the 58 minus 28, and you can see it didn't pull back as much as the modified binders, meaning that they have more flexibility. The last test that Howard did was he took the samples and he froze them, and then he dropped them from a height of about 3 feet to measure their flexibility. And what's interesting was when we think about the 58 minus 28 being the softest binder, it shattered. It was that first one. Here's the last sample, the 76 minus 34 drop from like when you slow it down in slow-mo, you can actually even see it flex, and it doesn't shake and doesn't shatter. That's the concept of the material, the liquid binder that they're using in Utah for their high mod projects. They're also paving in thick lifts, which is kind of contrary to what we've seen for a long time throughout the history of your career. They're paving in 6 to 8 inch lifts, but doing it in one pass. Your concern would be, are they able to achieve density compaction in that? Yes, because of the volume of binder that they're putting in the mixes. It's typically in the 6% and higher as opposed to the 5%. So they're putting about 20% more mix or liquid in there. They're putting in a higher quality binder, and they're getting incredible performance for elastic recovery and compaction. So here is their Roads of Tomorrow. This is the cover of their magazine that they published there in Utah. That they're talking about the implementation of high mod in Utah. Their target density is 96%, and they've met that in the 50 projects, 45 projects that they've done in their pavements with the high mod is more rut resistant than our previous super paved mixes. The high mod binder allows higher binder contents by about 20%. Wrap is allowed in the surface course of these high mod mixes, and they're using a regular dense graded aggregates. They're not using a gap graded aggregates like what would be required in an OGFC or an SMA or something like that. So that impacts or helps control costs when you don't have to do as much crushing and stockpile management when you have gap graded mixes. Moving on to some other tools and resources that are available for you in the industry right now. The Asphalt Institute has recently issued their odor management tool. It's a 33-page technical document that you can download off of their website right now. It explains how odors are formed. It explains how they're perceived, how they're measured. It gives them some details and insights into the chemistry, detection thresholds, and some actionable solutions to reduce odor impacts. So if you're on the production side or the industry side, this is a wonderful tool that I would point you to. And they've also got some pre-recorded webinars, a three-part webinar program specifically about this odor management tool. It's an excellent resource if you're looking for some impacts for odor management. Another excellent resource that I would draw your attention to comes from NCAT, the National Center for Asphalt Technology, and some of the research that they have as it relates to pavement design. Pavement design structural coefficients, meaning the strength parameter that is assigned to the mixes as a variable, has the single greatest impact on all design variabilities. Variables, excuse me. So what we're looking at here is the initial construction of the test track in 2000. It was 24 inches of hot mix. It's a sea of asphalt there because this was the very first iteration. It was built to be perpetual, so they could control the distresses that they wanted to control, that they didn't have these other impacts. We've since learned that 24 inches, we've far exceeded that, and that perpetual number is much less than that, depending on where you are in the country and what kind of materials you are. But I would draw your attention to NCAT to take a look if you're doing design work in the engineering sector, to make sure you are using and have some justification for using these higher structural coefficients. It's been well documented. The Alabama Department of Transportation has been using a recalibrated structural coefficient for since 2009. And Dr. David Tim, who's one of the lead investigators and authors of this report, he puts it very well. The way he talks about it is Alabama has moved past the risk window. So they've been using these structural coefficients since 2009. If it was going to fail, and they did through research, it wasn't. But if it was, it would have happened already. So I love that concept of they've already moved out past the risk window. As we wrap up our presentation, I'll share a couple of examples of sustainability. Some of you across the country and states, this is very important to you, and it's a key component of your industry right now. Other states are not in that sector as far as the environmental product declarations, and I'll talk about that in a minute. But this, allowing alternatives to hydrated lime, can make a significant impact to your environmental sustainability footprint. So we know that hydrated lime is added to a mix as an anti-strip additive to keep the liquid binder adherence to the aggregate. But there are other alternatives to that in forms of liquid anti-strip or chemicals that can be added at the plant during production. So there are still some states that do not allow for the inclusion of liquid anti-strip, and which have additional properties as compactive aids, warm mix additives, etc. They can serve a lot of purposes. So we're not suggesting that you abandon hydrated lime, but if maybe it's a and application, not an or. If you're not allowing for the application of uh, anti-liquid, anti-strip, that's something that you might consider. Environmental product declarations. The National Asphalt Pavement Association is leading the way with their development of the Emerald Eco Label tool. So you can see highlighted some of the states that are well along that route that have implemented low carbon transportation states or environmental product declarations. We don't see it across the country, but there are some key markets that are moving forward. Colorado is one of them, where I happen to live right now. Now, if you're in one of those states that does not have environmental product declarations, you might say, this doesn't apply to us. I would say be careful because in the commercial market, we're also seeing this, and NAPA's doing a great job of engaging with industry on the commercial and the private market. We are seeing large companies like Amazon and Google and large civil construct companies, Turner and Skanska, that are building data centers across the country that have requirements for environmental product declarations as part of their bidding and procurement. So just that even though your DOT may not require it, if you're doing work in the private sector, be aware that this is a growing segment of the sector. What is an environmental product declaration for those of you that might need a 10-second refresher? By definition, it reports the equivalent amount in kilograms of CO2 that are created to produce 1 ton of asphalt. That's all it is. How much CO2 equivalent is created to make, not place, but make 1 ton of asphalt? A simpler way to think about that is if you take the term equivalent kilograms of CO2, take that out, and just substitute the word energy in there instead. It's an easier way to think about this. How much energy does it take to make 1 ton of asphalt? Okay, I can get my head around that. I understand what we're talking about. So when we talk about the pavement life cycle, EPDs right now are only focusing on quadrants A1, A2, A3. The materials themselves, transport, and production. Materials. How much energy does it take at the quarry to extract with a traco to extract the aggregate out of the ground? How much energy does it take to run it through the crusher? How much energy does it take to put it in a stockpile and manage those stockpiles? That's the material side. How much energy does it take to transport those materials? If you're lucky enough and your plant is actually located in the quarry, you're going to have lower transportation energy costs because your stockpiles are going to be right there. But your quarry, you might be 10 miles down the road. And so you have an energy cost. Are you going to rail it from out of state? Are you going to put it on a barge and send it down the eastern seaboard? Or do you just have to put it in a truck and drive it 5 miles to your plant? Those are energy costs associated with that. Then once you get all of those materials to the plant, how much energy does it cost to run your plant? Is it a newer, more energy efficient plant? Is it an old plant? Is it using waste oil? Is it using natural gas? What's the heat source to dry the aggregates? So you can see when we start to put all of this information together, that's tracking how much energy is it to create that 1 ton of asphalt, get it in the back of a truck and get it to the gate. That's where we stop measuring today. But you can see through the rest of the pavement life cycle, the framework is there to develop and implement the segments A4 and A5, which will be coming at some point. A4 is the construction segment of the life cycle, and A5 is the performance and long-term use. So this is the concept of what an environmental product declaration is. What impacts an environmental product declaration? If you look at a sensitivity analysis, the number one largest impact to an environmental EPD is the percentage of virgin binder that is used in the mix. Number two sensitivity impact is the plant, is the heat source that's at the plant, and then number three is your transport, and that's very subjective based on your locale, where you are in the United States, and the plant. But your number one and number two, how much virgin binder are you using in the mix, and what kind of heat source are you using at the plant to dry the aggregates when you're making your mixes. Another trend that I draw attention to from the equipment side is just be aware of what we're seeing. This was we could see this just last month at Con Expo in Las Vegas is the changes in equipment. And this is the three-dimensional asphalt screed as opposed to the flat screed that you're you're seeing about 91% density coming out behind the screed just because of this textured screed plate that so how is this going to impact construction? Is this going to change or have the ability to change your paving train? Are you going to be able to remove one of your rollers? Do you just have a rubber tire roller and a finish roller? Do you need the breakdown roller? Well, that's up to the contractor to see what they do. But there's an impact here with changes in construction and technology. So we're going to wrap this up as I've pointed out some problems, some funding challenges, impacts to program delivery, some solutions that we can look at to address some of those program delivery in terms of additives, um, high mod mixes, etc. What's the gatekeeper? What's holding industry back from moving forward with some of these things? And so our final two slides here, what's impacting the pace of progress? Why are DOTs moving slowly on innovation? And this isn't intended to be confrontational with the DOTs. Simply, this is the way the DOTs are operating. DOTs are risk managed organizations. They're publicly accountable, and that drives their conservative decision making. I've heard them to talk about this before. Trust is their currency. That's all they have, is they have their trust back to their governors and their state legislatures. That's it. And so they're conservative by nature to maintain that trust. That's all. So it's difficult to move the needle and change this pace of progress with that. Another challenge with the DOTs on the slow innovation is the long project life cycles and multi-year budgets make innovation challenging. It's hard to have one and done to get performance over long-term range. Barriers to implementing new technologies. Specification lag. This is a big one. Outdated standards, and I think everybody on live would recognize the challenge of keeping your specifications current and up to date. But outdated standards make it hard to approve new materials or new mix designs or methodologies to develop those mix designs. If it's not in the spec, we can't do it. That's a huge challenge to where we go trying to move the needle. Procurement restraints. These are low bid systems for public agencies, and that low bid system discourages risk taking. Fragmented communication. And this is a biggie. So, innovation, when a DOT does do something that's innovative, that innovation typically stays within those small pilot projects. It's usually not scaled out nationwide, or excuse me, statewide, or within from district to district to district. It's that siloing by design and in nature that we have at the DOTs that can make it very difficult for this fragmented communication. So here in our last 10 minutes, Amberly, if we have any questions, I'm going to turn it over to you here in a minute just to read some questions. But I do just want to thank everybody for joining us today and point out some resources that we have available for you. The engineering team and the resources that you find at Napa, the engineering team, the regional engineers that you find at the Asphalt Institute, your 40 regional SAPAs, and then the incredible research and documentation that comes out of NCAT. These are all incredible resources. And then you can always reach out to us here at the Asphalt Pavement Alliance with any additional technical questions. So those of you that have joined us for the full presentation, if you need a PDH certificate, I'll leave this up here for a moment where you can just grab a screenshot of this. This will also be included on the video on YouTube. Those of you that need some documentation, we leave it up to you to maintain your own record of attendance. But with that,